All right, one more problem here, getting a little harder. So now I want the area of the largest area of the rectangle that can be inscribed into the circle. All right, so still the length will be 2x. And let's think about the height. The height will be 2y. All right, so my area equation will be 2x times 2y. And you know that the y I need to get from solving this. So if I take y squared is equal to 16 minus x squared, y is equal to the square root of 16 minus x squared. So I get 4x and then square root of 16 minus x squared. Product rule happening, right? Lots of very similar to what I just did, being careful with those negative exponents. Carrying this down, let's do it. A prime first, d second. So 1/2. And remember, this is a very tricky, easy thing to forget. 16 minus x squared times the derivative of the inside plus, then carry this, times 4, the derivative of 4x. Okay, let's see what we got going on here. I've got this negative 2x, this 2, 1/2, and this 4. So I think all of this, these 2's cancel, so I get 4x squared. And again, I'm going to bring this negative exponent guy into the denominator. And, oops, I forgot the negative. And then plus 4, 16 minus x squared. Oh, this is very familiar, right? Set it equal to 0. Move this to the other side. Equals 4x squared root 16 minus x squared. Okay, let's see what I've got going on. Let me bracket it off here. That's what I've got, right? I can see the 4's cancel. I can see that if I multiply both sides by the radical, the 2 radicals cancel on this side, and here I get 16 minus x squared. 16 is 2x squared, 8 is x squared, so plus or minus root 8 is x. All right, then if I plug that back into here, right, y equals 16 minus, and I'm plugging in root 8, so I'll get 8. So then the y would be root 8 as well. Oh, will you look at that? It's a square. Okay, last one here on this page. So here, this is going to be a more challenging one, so I'll make sure you're being very careful about the algebra. So here they're telling me I've got the surface area. So 1,000 is the surface area. Okay, what do they tell me? It's got a square base, x and x, and an open top. So that means I've got a bottom of x squared, and I've also got 4 sides of area xh. So that's my constraint. What is it I'm trying to maximize? Volume. I know volume would be x squared h. Okay, I know I'm going to have to solve this for the letter h to substitute it in, right? 1,000 minus x squared over 4x is h. And I'm going to take the time to fix this, right? So you know that this 1,000 over 4 is 250 over x minus 1/4 x, right? That would be my h. So I'm going to plug it into here. So I get volume is x squared times 250 over x minus 1/4 x. All right, so now I'm going to multiply this out. I'm really not a fan of doing product rule if I don't have to. So if I multiply this times this, I get 250x. Well, that's kind of nice. And if I multiply this times this, I get minus 1/4 x cubed. Okay, let's take the derivative. So this would be 250 minus 3/4 x squared. Set it equal to 0. 3/4 x squared is 250. X squared multiplied by 4. That gives us 1,000. And then divide it by 3. I'm just going to leave it like that. So then x squared, x is 1,000 over 3 to the 1/2 power. Okay, that's the x. How do I find the h? Oh, well, you look at that. It's right here. So the h will be 250 over 1,000 over 3 to the 1/2 power minus 1/4. 1,000 over 3 to the 1/2 power. Ugly. It is what it is.